Greetings and welcome to the Chemistry 223 Chemical Equilibrium Lab. This is also known as Le Chatelier's Principle Lab, and as you'll see, this is a big part of what we're going to be learning about today. Le Chatelier's Principle is an important part of chemistry, and basically it helps scientists to understand how a reaction reacts to stress. And by stress, I don't mean, oh my gosh, coronavirus or something like that. What I mean by stress in this case is like if you add a reactant, that tends to disturb the equilibrium, or if you remove a product. And you can also extend it to things like changes to temperature and pressure even, which is pretty cool. Le Chatelier, whose picture there is in the lower right corner, was the person that came up with this idea. And it says, formally, if a system at equilibrium is disturbed, the system tends to shift its equilibrium position to counter the effect of the disturbance. And if you're looking at me with glassed eyes at this point, I completely understand. Let me try and give you some examples. At the top here, we have some random chemical reaction where reactant A is converting to product B. And this is an exothermic reaction because heat is being generated. It's a product. And an endothermic reaction would mean that heat, of course, was a reactant. But this reaction is exothermic. And really what Le Chatelier's principle comes down to is that if you add something, the reaction shifts to the opposite side. And if you take away something, the reaction shifts to the side that you're taking it away from. And I want you to keep that in mind as we go through these. So the first one's at the top here, adding things like adding more A. Notice how as you add more A, it says reaction shifts to the right. So you're adding a reactant and the reaction shifts to the opposite side. It shifts to the products. Notice this terminology. Right is basically an acronym for a shift to the product side. And left, which is an example of the next one, left means that it's shifting to the reactant side. So again, right in this context means products and left means reactants. So again, if you add something, the reaction shifts to the opposite side. So you add A, it shifts to the side with B. It's going to shift to the right because A is a reactant. And the second one there, as you add more B, a product, now the reaction's going to shift to the left, to the reactant side. So again, you add something, it goes to the opposite side. This also applies to heat. Now in this example, this is an exothermic reaction. So let's say we increase the temperature. That's like adding heat. And by Le Chatelier's principle, if you add anything, even heat, it's going to try and get away from it. So in this problem, if you increase the temperature and it's exothermic, it's going to shift to the reactant side, to the left side. Heat is just like a reactant or product. Now, the lower examples are the same thing, except now we're taking away instead of adding to. And if you take it away, it's going to shift to the side that you're taking it away from. So if you start removing reactant from this reaction, the reaction's going to shift to the side with the A. It's going to shift to the left, the reactant side. If you start to remove B, a product, which is much more common, by the way, if you remove B, a product, the reaction is going to start shifting to the right. So if you want to make a lot of product, you're going to try and get that product out of the equilibrium. Maybe you can filter it fast or something like that, because you remove something and the reaction shifts to the side that you removed. So it shifts in this case to the product side. And this does apply to heat as well. Now in this exothermic reaction, if we started to remove heat, which in this context means cool it down, the reaction will start to shift to the side where heat is a product. And in this context, that means this is going to be a shift to the product side. So if you have an exothermic reaction, you want to cool it down probably a little bit to get the maximum yield, because shifting the reaction to the right is possible if you cool it down. You're taking the heat away from the exothermic reaction to make more product. Now, of course, as this was endothermic, you'd have to flip both of these around. It wouldn't be the same thing. Okay, so in this lab, there are basically four what I call goals. Think of them as like four sections, and each section will help you to understand a particular part of Le Chatelier's principle and how it applies to chemistry. I'm going to show a video now which shows little highlights from each of those four sections, and hopefully that'll help you to understand what's happening, get a better idea of what's going on. Okay, so I think it's time for a video. Again, if you have questions on anything, make sure you reach out to me. You can also talk to the Learning Success Center, Avid Center. They are there to help you as well. Okay, good luck with the lab. Have a great day. Let's watch the video.